Hello everyone. So today we're going to talk about limits with absolute value. But before we get started with talking about limits, let's first just talk about the absolute value function. So the absolute value function looks like what I have highlighted in orange there. It's f of x equals the absolute value of x. And below here, you can see a graph of what the function absolute value of x looks like. So to make sense of the graph, just think of like if I asked you what the absolute value of 5 is. You would say that the absolute value of 5 is just 5, right? So whatever you plug into the absolute value, it's that same value, but just making sure that it's positive, right? Because here, when I have the absolute value of negative 5, it's positive 5. Okay, so basically make sure that when you're taking the absolute value of a negative number, it becomes positive. Alright, so here you can kind of see that with these points that I sort of highlighted, but let me just highlight them in a red color. So when I plug in negative 1 into the absolute value function, I will get out 1, right? Because negative 1 is a negative number, but within the absolute value, it becomes, the output would be positive 1. And then same idea with negative 2. When I plug in negative 2 into absolute value, I'm going to get positive 2. And then, of course, if I plug in positive numbers, it just stays the same. So the absolute value of 1, for example, is just 1. Absolute value of 2 is 2, and so on and so forth. So that's what creates this V-looking shape of the graph. So now you're probably wondering, like, how do I actually compute the limit, though, of functions with absolute value? Well, what's going to happen here is we're going to have to rewrite the absolute value function as a piecewise function. And then that way, once I rewrite it as a piecewise function, I can compute left-handed and right-handed limits like we've been doing with piecewise functions. So once we rewrite it, it will seem like stuff you've already seen before. Okay, but we just have to talk about how to actually go about doing that, right? So here I'm saying that for the general form is you can define the absolute value function as a piecewise function where the absolute value of x is equal to x when x is greater than or equal to 0, and negative x when x is less than 0. So basically what this is saying is that whenever x is positive, whatever my input is my output, and whenever x is negative, then I need to multiply that by a negative to get my output. So here, based on this, right, the absolute value of 5 is, of course, 5. So you can see how my input is the same as my output, right? So that's what it's saying here. When I plug in x and x is positive, I'm going to get out x. Now, when x is negative, though, what happens is it becomes 5, right? But it's not negative 5, so it's negative of whatever my input is, which is 5. So it's negative times my input. So here, I'm just going to show you, it ends up being negative times input value. Okay, and so that's basically how those pieces are coming about. Like, that's what's happening there to describe how they wrote it as a piecewise function. Okay, because they basically had to think, all right, well, I know that when I plug in a negative number, it becomes positive, and when I plug in a positive number, it's just the same thing. How can I actually rewrite that, though, as a piecewise function? All right, so hopefully you can sort of see where that's coming from now, but how do I rewrite it if I have, like, instead of just the absolute value of x, what about the absolute value of x minus 4? Well, the same idea happens where I'm going to have my two pieces, and my input in this case is x minus 4. So here, I'm saying that I'm going to get out my same input as long as x minus 4 is greater than or equal to 0. Okay, so as long as this input here is greater than or equal to 0, then my input is going to be the same as my output. But what happens here is that for this part, I have negative of x minus 4 when x minus 4 is less than 0. Right, so basically I'm saying whenever my input like that, which is in this case x minus 4, is less than 0, it's negative, I'm going to have a negative times whatever my input was. Okay, so now you can see, right, but on these conditions over here on the right, like x minus 4 is greater than or equal to 0 and x minus 4 is less than 0, I want to have it so that I know, like, I have x, for example, is greater than or equal to something, or x is less than something. So what I'm going to do is just simplify this. I'm going to solve these equations here on the right, and I'm going to say this is x minus 4 when x is greater than or equal to 4 by adding 4 to both sides. So I'll just show you over here. Right, I have x minus 4 is greater than or equal to 0. Add 4, x is greater than or equal to 4. That's how I'm getting that piece. And then the same idea is happening here, where I'm just in this case going to get x is less than 4, because I'm going to have x minus 4 is less than 0. Add 4. So I have x is less than 4. Okay, so ultimately here I'm saying that I can rewrite the absolute value of x minus 4 as this piecewise function. Okay, so you don't necessarily have to show me the step above it, but I do want to show you where I'm getting x is greater than or equal to 4 and x is less than 4. It's basically the same format as what's up here. Instead of writing x, though, I'm writing x minus 4s.